Yes, ma'am.
Good morning, sir.
Okay, please confirm you have started the recording. So you all are prospective UG and PG students, and I hope nobody is from the existing batch of MBA, Gen AI particularly. Is there anybody who has already enrolled himself for MBA, Gen AI? Why I'm asking is I covered a portion on the national strategy for AI and some system consideration last night. So if you have joined again, because this forum is meant for prospective students, it's a preparatory lecture. In case you've joined again, you're going to have the you should have the patience to hear it all again. Okay, assume nobody is already existing student and everyone is a prospective student. Okay, fine.
Sir, good morning. This side Jamangal from IIT Patna. So I welcome all the aspirants of IIT Patna and Triple IT Ranchi. Ashish, Karan sir, you are also welcome in this session. This is the first preparatory classes. And dear students, basically the preparatory classes is just it's not there is not any particular syllabus for that. Basically, we cover all the fundamentals of IT and management part, which is basically necessary to make the foundation of every professional. So here all the PG students are. Few are from the MCA, few are from the MTech, few are from the MBA, few are from the MBA Gen I and product management. So basically, the preparatory classes generally we schedule on Saturday and Sunday. So students, if you have any query regarding your courses or any program, if you have general inquiries, you can connect with me also as well as to your academic counselor. And you are not basically requested to ask any operations related questions from the faculty. So faculty is basically for only the cover that your topic. Uh, so in case of you all are requested to kindly note my WhatsApp number. It's a 9889502400. Again, I am asking 9889502400. In case of any operational related issue, you can connect with me on my WhatsApp number.
Sir, you
If you could repeat
And
once again, sorry.
repeat.
989.
Sir, put,
9889.
put in chat, please. Put in chat, please.
Okay, I will write in the chat box also, as well as I am admin in the WhatsApp group in which we have invited you all. So once again, welcome to you all. And Ashish sir, please start your session.
Okay, thank you. So okay, so let's start by understanding why India's AI potential is exceptionally significant, uh, both nationally and globally. So we are studying about AI. You have the people, the students who wants to join the MBA Gen AI courses. There are students who wants to learn cybersecurity. All these are somewhere connected. Okay. So I'll tell you a small story. So back in 2019, you know, India's national strategy for AI, which is often referenced as NSAI in policy circles, place AI at the center of the country's digital transformation agenda. Okay. And why? Because it highlighted the AI's ability to boost economic growth and contribute significantly to GDP. Okay. That was the main reason India realized that AI has the potential to add trillions and trillions to India's economy by 2035. Okay, and whenever I say that, I always quote a small example which happened 1.5 years back, or rather 1 year back when okay, so let's reverse a little. Let go back and let me tell you the era when computers were coming. So anybody who was manufacturing computers, developing softwares were allowed to come in, advertise, market. The Indian market was open for everyone. Okay. Now, fast forward to 2018, 19, 18 and 19, there were already countries which have tried AI, certain application. As we move ahead, we will discuss some of the examples. And some of the application had failed. Some of the application was a success. So there were some lessons learned. Okay. So uh, the leaders realized that it is very important to make a conducive environment in the country so that we can fully encash the AI potential. And when I say that, there was uh, by making a conducive environment means um amending the legal landscapes. So we have DPDPA now. There was a plan for AI law also, but it is yet to come. Then a lot of amendments have taken place in when it concerns with personal data or privacy. Okay, so unlike other countries which have already laws in place, our country was struggling at that time back in 2019. And during a budget speech in 2018, the mandate was given to Niti Aayog to come up with a policy. And that policy was called the National Strategy for AI. Okay. And that will recommend what all India should do to make AI adoption smoother. Okay. So I remember there is an example that this time when the Google Gemini was coming up and then it was struggling to give correct results. And at that time, for whatever reason, it made an adverse remarks on the about the honorable PM. And when that happens, you know what will happen. So automatically the entire machinery was, it's swung into action. The cabinet minister rebuked the Google. The minister of state rebuked the Google. The ministry came up with a policy that they will not allow any AI application to just get introduced just like that, and launch it without much of testing and all. So they devised a small policy that will have to go through some kind of testing, but they realize that by doing that, they will create a major hurdle for the AI adoption. And even if that kind of sensitive thing will happen, somebody making an adverse remark about the country's honorable PM, even after that, the entire policy, all these activities happened within a week's time, but everything was revoked. It was rolled back. Okay, so that is the significance that of this thing, and that is the objective and the determination of the country to ensure that AI is adopted well in the country. Okay. So obviously, it's going to, as I said, it's going to add trillions and trillions of dollars to the Indian economy, and that is probably one of the reasons: economic and productivity potential, talent and ecosystem advantage. So there are a lot of plus signs to it. India already holds a large share of global AI talent pool. Around 16% of the world's AI professionals. Probably India is geographically placed in such a way that it can be um, a talent pool for AI. So all those things I'll just leave because now we are sitting in 2026. So I'm sure everybody, whether you're in the cybersecurity field, you are an engineer, AI is the buzzword, cybersecurity is the buzzword, and if you're a business student or a working professional, AI has found applications in almost every sphere of the every industry, every domain. So we'll skip this and I spoke about this 2018 budget, which triggered the entire process, and then Niti Aayog came up with the national strategy of AI document. You must go through if you want to, whether you are an engineer or you are a business student or you are a public policy student. You must go through national strategy for AI document, and then after that, it also came up with a responsible AI document in 2021. So NSI came up in 2019, responsible AI document. So responsible AI was the terminology which was coined by the Indian government, by the Niti Aayog. And they knew that AI will have a widespread. So it's not only that, they had to trigger the entire ecosystem. So a lot of activities happened at the skill level where a Ministry of Skill India and entrepreneurship was established. They were pushed, a lot of skilling programs were initiated, AI youth camp, vocational training, a lot of center of excellence were established in IITs, IIMs, and it's still being done in AI, in cybersecurity, in telecom, and all related fields. A lot of research funding went into this, and still the funds are being increased. In fact, if you know the the stipend or the fellowship which is being given, they have also been increased to that extent. Um, and this is probably the perfect time for industry academia mergers. There are a lot of projects which are coming where the industry is giving the use cases to academia and academia is trying to come up with a solution. You must have seen the previous UGC chairman speaking. They have come up with new policies, provide probably the best time for a person, for a working professional to do a PhD. They have relaxed norms, they have customized, tweaked the process, and done a lot of stuff. So it is the entire triggering of the entire ecosystem because probably they were aware that AI will not be restricted to one thing. That's why if you see AI, there's no AI ministry as such. It is spread across the ministries, across every domain. So because they had imagined that it's going to have widespread. There were some use cases, prime use cases, which was mentioned in the national strategy document back in 2019. Smart mobility, agriculture, education, healthcare were some of them. But uh, coming to the current times, you know, there are plenty of use cases, and they are not just restricted to these. Okay, so why am I talking about this? And then this responsible AI document came in 2021, which gave the principles of guiding ethical AI deployment and all. But why am I talking about this? Okay, and I'm sure you must be knowing this. Okay, let's quickly cover this. But the reason why I'm telling you this is because of this. So when you buy a product, or when you start developing a product, you are given a set of prerequisite, a tech specs kind of thing, or some considerations of what the product will do. Okay, so national strategy document rolled out with some system considerations. They said irrespective, they're not getting into the technical side of it, but they said that there are certain system consideration, to be specific, 7 of them, which has to be part of any AI product. Okay, so if you're an engineer, if you are an AI manager or an AI product manager, so whether you are in the public policy domain, engineering domain, or you are into the business domain, you must know these system considerations. They have been derived from the mistakes which has been done or the AI application which has been tried by the countries who took initiative and they did first. So we will go through them one by one. But just before that, since this is a lecture which talks about the artificial intelligence, and as Mr. Raj said, that we need to cover a little bit of basics. So we'll start with this. Okay, some basic stuff, and then we move to the system considerations. Okay. So let's understand what artificial intelligence is. Might be repetitive for them, but let me go through it for the sake of people who are too completely ignorant about this. So AI. What is AI? So artificial intelligence is basically the capability of machines to perform cognitive tasks that normally requires human intelligence, okay, such as thinking, perceiving, learning, problem solving, decision making, okay? Because AI is not just a technology, it is a business capability. That's why it also matters to business leaders, because AI is about building systems that can learn from data, can make predictions, can automate decisions, optimize outcomes, and improve over time. Most important. Okay, this means AI is fundamentally a strategic asset. Okay, so if I have to describe in business terms, um, or into management language, it becomes that AI is a system that converts data into decisions and actions. So in any organization, AI can be used to improve efficiency, reduce cost, enhance customer experience, create new products, and transform operations. Okay. But also AI has a governance challenge. Okay, so I always keep telling my cybersecurity students, if you are a cybersecurity professional, you must know what is ISO 27001, because it is the International Standards Organization standard and best industry practices which are accepted worldwide. Similarly, if you are an AI student, even if you are a technical person or a manager or into governance, you must know ISO 42001. Okay. So, and similarly, you must have gone through National NSAI and Responsible AI document of the country. Must keep track of the latest development, the amendments in legal domain like DPDPA, Digital Personal Data Protection Act. Okay. Earlier, for any organization who has, say, used to do ISO 27001 compliance just to get the clients and or flaunt about it, but now there is a legal thing attached to it. I hope you know the fine in DPDPA is to the tune of 240 to 50 crores. Okay. And over a period of time, that's why you have seen that there is a parallel vertical which has come up in any organization, be it government or corporate, and that is cybersecurity. And very soon you will find another parallel coming up, which is AI. Okay, so it is that the strategy from digitization strategy is changing to AI strategy. Okay, since I have to cover system consideration, I've got very less time. I'll quickly jump to that. Okay, let me just finish the different branches. I'm sure you must be aware of that, but just quickly go through them. Machine learning. So machine learning is the most widely used branch of AI. Okay, so what does it do? It allows systems to learn from data and improve over time without being explicitly programmed. Okay, what is the business impact? You know, for my business students, it can help in predicting customer churn, forecast demand, detect fraud, and optimize pricing. And there are many other use cases, there are plenty of them. Let's talk about robotics. So robotics combines AI with physical machine. Okay. So what does it do? Robots can perform tasks. Please mute your mics, please. Let me finish the lecture. I'll take the questions, at the end. Robots can perform tasks in the physical world, or you can write down in the chat box. Robots can perform tasks in the physical world from manufacturing to healthcare. Then we have natural language processing. So NLP basically enables machine to understand and generate human language. Okay, you have already found, we have already seen the application in chatbots and virtual assistants. So somebody calling you from real estate, probably the first person who's calling you might be if you're chatting, it might be a chatbot or a virtual assistant. And based on that, based on your response, it picks up and then escalates it and give it to an actual person. Computer vision. So computer vision allows machine to interpret visual information like images and videos, and it's got use cases in face recognition, quality inspection in manufacturing, object detection in retail, and very important, autonomous vehicles. Then we have neural networks. So these are AI models inspired by the human brain itself. Okay, they power advanced AI applications like speech recognition, image analysis, and deep learning. Okay, so job is complex pattern recognition or predictive analytics, or maybe in the recommendation systems. Fuzzy logic. So fuzzy logic deals with uncertainty and imprecision. Okay, so what does it do? It allows systems to make decisions in situations where the answer is not simply yes or no. So they find its applications in control systems, risk assessments, and even decision support systems. Last on my slide, expert systems. So expert systems mimic human expert decision making. Okay, what does it do? They are rules and knowledge bases to provide recommendations. Okay, also brief about LLM. So LLM are type of AI model. We've all been using LLMs, and these are trained on massive amounts of text data to understand and generate language. So they can write text, they can summarize, translate. So we all are already using chat GPTs and all that. Agentic AI. Agentic AI refers to AI systems that can act autonomously, make decisions, and carry out tasks with minimal human interventions. Okay, so they operate like an agent that can plan, act, and learn, and can manage multi-step workflow and also adapt based on outcomes. Okay, so you can have an agent which builds a strategy or analyze market data or execute campaigns. Okay, so the point which I'm trying to make from this slide is these AI branches represents the building blocks of modern AI systems. Okay, and we're already using LLMs. These are the language engines uh, driving many applications today, and not to forget agentic AI, which is the uh, the next step, probably, or already we are in caching it, where AI becomes autonomous and action oriented. Okay, now I'll skip all these slides and come straight to system considerations. Okay. Okay. So again, I would like to have your attention. These system considerations are like basic requirements from any AI system. Basics. Okay. Not getting into the technical side of it, but basics. And these have been derived from the Constitution of India. Some of them you must have heard about the principles, basic principles, fairness, ethical, responsible, explainability, all those. And also from the lessons learned from countries uh, which have already deployed AI applications. Okay, and then they found some issues with that. There were some adoption issues. That's why that's why that's why it is very important uh, that if you decide to manufacture an AI product, the first thing is you decide whether this should be done at the first place or not. Okay, so even if you are an engineer, you are a management professional, or you're into governance of AI, these considerations are important to you. Okay, let's go through them one by one. First is understanding the AI system's functioning for safe and reliable deployment. Okay, I'll just read out the abstract from the strategy document, then I'll explain to you. Okay, so the issue is while uh, accuracy gives a reasonable view into how a system performs, understanding decision-making process is important to ensure safe and reliable deployment. Its implication, the system could pick spurious correlations in the underlying data, leading to good accuracy in test data sets, but significant errors in deployment. No problem if you didn't get this. I'm going to explain it with the help of example. Okay, so what does this mean? Let me explain it to you. So machine learning models learn by identifying relationships between input features and output levels. Okay, Let me put it in simple terms. The model is learning if X happens, then Y. So it tries to figure out a relationship between X and Y, the input and the output. So to evaluate these models, we typically hold out a portion of the data set as a test data set. And this is meant to simulate how the model will perform on new data. But here is the challenge. However, the test data set does, however, the test data set, the data which you feed, AI is like a child. You need to feed food to the AI. So whatever you feed during training, you can't launch a child into production network, right? You need to feed it, let it grow intellectually, and when he is in a at a position when he can be put to production network, then you do it. So like you grow the child, you grow the AI model by feeding it data, and the data which is fed in during training is called test data set. So the test data does not always reflect the real world. That is the main issue. And in the real world, data distribution can change. New patterns can appear. The environment can be different, and business conditions can also shift. So even if the model performs well, and this is a very important line, and this is what the issue is, even if the model performs well in the test data set, we cannot be sure how it will behave in a real deployment environment. Okay. So just to paraphrase the issue, the biggest problem arises when we do not understand the relationship between the input features and the output. We may not know why the model is making a decision. And this makes it difficult to predict performance in a new environment or in production environment. So deploying and scaling such AI systems become risky. Even if you have not understood so far, no problem. I'll explain this thing, this beautiful, the first system consideration using this example. Okay. So this is based on the algorithm which the Ribeiro and his team gave in 2016. Okay. And it's a classical example for image classification. So the task was very simple. Classify whether an image contains a wolf or a husky. Okay. The model seemed to perform reasonably well on the test data. It had good accuracy and was giving the correct labels. But then the model was analyzed. So when researchers dug deeper, they found something. This is a wolf versus husky algorithm, very famous in AI. Okay, we are discussing that. So when researchers dug deep, they found something surprising. The model wasn't actually looking at the animal. Okay, so this algorithm was basically to distinguish between a wolf and a husky. And during test data in the training, it was performing beautifully. Okay, it was accurate, but then something went wrong, and we are discussing that. So when things started going wrong, the researchers dug deep and they found that the model or the algorithm was actually not looking at the animal. It was not looking at the facial features or the bodily features of the animal. Instead, it was focusing on the background of the image. Understood? So a model which is designed to distinguish between wolf and husky should ideally compare the facial features and bodily features and then make a call. But whatever training data was fed, it was perfectly giving the right answers. But when it started behaving abnormally, researchers dug deeper and they found that it was not actually looking at the animal. It was looking at the background. Now let me explain it to you. So in the training data, images of wolves were often taken in snowy environment. Okay, wolves. This is they're found in snow. So wolves had snowy background. Okay, so and images of huskies were often taken in non-snowy settings. So the model learned that if there is a snow background, it is wolf. If there is no snow background, it is husky. Now, what does this mean? So this is a classical case of spurious correlation. Okay, and the model learned the wrong feature, the background, instead of the actual animal. So although it performed well on the test data, it would fail in the real world. Okay, so you can imagine deploying such a model in real application. So if the model sees a husky in snow, it might label it as wolf because it learned it wrongly. And that would be a serious issue. So the key takeaway from this system consideration, number one, which has been given by the National Strategy for AI by the Niti Aayog Indian government, is that accuracy is not enough. We must understand the decision-making process. Okay, that's why it says understanding the AI systems functioning for safe and reliable deployment. So we must understand the decision-making process. We must ensure the model is using the right features. Otherwise, deployment becomes risky and unreliable. Okay, so this example shows why AI governance and model interpretability are critical, especially in business applications where decisions affect real people. Okay, let's switch to system consideration two. Post deployment, can the relevant stakeholders of the AI system understand why a specific decision was made? Okay, so in the previous slide, we talked about understanding the overall decision-making principles of the AI system. But in many real-world scenarios, individual decision matters. And people want to know why a particular decision was made. Okay, where is this? These kind of applications are you will find in credit scoring, loan eligibility, fraud detection, insurance qualification. And these decisions directly affect people's lives and livelihoods. Okay, so when an algorithm makes these decisions, users expect a factual and transparent assessment. So that's why explanation matters. Even from the legal and ethical point of view, explanations are important because they support procedural fairness. Okay. Now, what is the actual challenge? The challenge is that deep learning models are powerful, but they are often opaque, meaning they are like black boxes. On the other hand, simple linear models are interpretable, but their accuracy is usually lower than deep learning models. So what are the implications? It leads to lack of trust by users, discouraging adoption, difficulty in audit for compliance and liability. How will you audit when you don't know why and what rationale it is giving you a suggestion or a recommendation? Difficulty in debugging and improving the model, and inability to comply with sector regulations. Okay, so therefore, post-deployment explainability is not optional, it is essential. Okay, so main message here is explainability is a key pillar of AI governance and adoption. So whether you are engineering professional, you must ensure this is embedded in your product. Otherwise, your product will not be sold. Or if it managed to sell, there will be an adoption issues. And if you are into AI governance, ensure explainability is a part of that. Because if stakeholders cannot understand decisions, the system cannot be trusted or scaled. If you have not understood so far, no problem. Let me explain you with this simple example. So there was something called IBM Watson for oncology. Okay, this is a real world example that highlights why explainability is crucial for AI adoption. So in several hospitals, IBM Watson for oncology was deployed to assist doctors in diagnosing and recommending treatment plans for cancer patients. Okay, so the idea was simple: use AI to support physicians by providing evidence-based treatment options. But what happened in practice? A major problem arose. Watson's outputs were not explainable. So when the system agreed with physician, as long as the system was agreeing with physician, it was helpful. because it was like a confirmation. As per, if I'm a doctor, I'm using the IBM Watson services. For me, the output should be B, and IBM Watson is, as long as it's giving B, it's a confirmation for me, and I don't look for an explanation because I already decided the option should be B. Okay, but the issue was when Watson disagreed with physicians, then the reaction was even more serious because the system couldn't explain its reasoning. So doctors assume that, if it's not matching my judgment, since it's not matching my judgment, it might be wrong. And as a result, the system lost credibility and trust. So due to this lack of explainability and trust, many hospitals abandoned Watson for oncology. And this is a clear example of how a powerful AI system can fail, not because of technical accuracy, but because of lack of transparency and trust. Okay, so this shows that explainability is not just a technical feature, it is a business requirement. And if stakeholders cannot understand why a decision was made, they will not adopt the technology, especially in high stakes sectors like healthcare. Okay, key takeaways from this slide. Explainability is essential for adoption. Trust is not built by accuracy alone, and without explanation, AI systems can be rejected even if they are technically strong. Okay, let's go to system consideration 3. We have to cover 7 of them. It's already 11:10. So system consideration 3 says consistency across stakeholders. Okay, so now we come to the third system consideration. So, so many people believe that automated solutions bring objectivity to decision making. After all, a machine does not have emotions or personal opinions or political motives, right? But recent global cases have shown that AI solutions can be biased and sometimes biased against specific sections of society. Now, what does bias look like in real life? Now, this bias can lead to inconsistent outcomes across different demographic groups, even when the people are similarly qualified and placed. So in real life, the bias often reflects historical discrimination. I'll explain it to you with an example. Remember this term, historical discrimination, where members of certain caste, class, sex, sexual orientation, race, religion are denied opportunities, even when they are equal in all relevant aspects. Okay, so how does bias emerge in AI systems? Bias can be introduced at multiple stages of the AI life cycle. For example, if we talk about the rule-based systems, bias is introduced through the rules defined by developers. And if we talk about deep learning systems, bias is influenced by the data used, the model chosen, the parameters selected, the goals defined, and the environment in which the model learns. Okay. Now, why AI bias is more concerning than human bias? So human decisions are not free from bias. We all know that. But AI systems are particularly concerning because they can learn and reproduce human bias. Then they can amplify bias at scale. And once deployed, they can affect millions of decisions quickly. Okay. Now let me explain this with an example. So I'll talk about 2 real-world examples because these are examples not from my whims and fancies. These are the examples which are taken by the government of India, by NITI Aayog, and they have explained in the National Strategy Responsible AI document, and they have explained the rationale behind formulation of this system consideration. So I'm reading it from there. Okay. So in 2015, very interesting case. Amazon experimented with a machine learning system to evaluate job applicants. Okay, so the system analyzed resumes from the past 10 years to learn patterns of successful candidates. However, the results were biased. Okay, So what went wrong? The system rated male applicants higher than female applicants. So that is what the system was doing. Why? Because historically, more men applied to Amazon. They fed the model the 10 years data. In the 10 years data, as per the 10 years data, more men had applied. So obviously data had more men applicants and the data reflected a preference for male candidates. So you can figure out if there will be, so out of 10, if the 9 are men, obviously the selection of men will be much higher than women. Okay, so historically more men applied to Amazon. The data reflected a preference for male candidates because the more male candidates were selected. And therefore the model learned this pattern and assumed it was the correct way to hire. So what was the outcome? So Amazon system taught itself that male candidates were preferable. And this is a clear example of how AI can reproduce and amplify historical discrimination. Okay, allow me to explain this with another example. So you must have done KYCs, bank KYCs, where you need to blink your, blink, uh, or when you go for passport renewals, the staff telling you to, when you look in the camera, it asks you to blink. So this is a passport photo blink checker. And this is the second example that we are going to discuss now. So that made headlines, which involved an AI systems which used to check if a person blinked in passport photos or not. Okay, now this system performed poorly for people of Asian descent. I repeat, the system performed poorly for people of Asian descent. And why did this happen? Because the training data set lacked sufficient Asian faces. They didn't include Asian faces in the training data set. Obviously, if you see, Asians have got a different facial features. They have some have very little eyebrows and all. So their blinking may be different. Now that needs to be recorded during the training, but they missed that fact. They didn't include Asian faces. So the model was not able to correctly recognize blinking patterns in that zone, in that demographic. Okay. So both examples basically show the bias, that bias is not just a technical problem. It is a business and social problem. Okay. So the key takeaways from this consideration is AI models can learn historical discrimination from data. Bias systems can reinforce unfair practices. Biased AI leads to loss of trust and brand reputation, and it can cause legal and regulatory consequences as well. And of course, it harms social equity and can disrupt social order. Okay. So AI system must be designed, trained, and tested with fairness and diversity in mind. Okay, so now we graduate to system consideration 4. And this talks about incorrect decision leading to exclusion from access to service or benefits. Okay, incorrect decision leading to exclusion from access to services or benefits. This is the system consideration 4. Okay, all these 7 considerations should be catered for when you are taking a call of developing an AI product. If you have not done that before final, you must ensure these basic considerations are complied with. So AI systems are inherently probabilistic, meaning they make predictions based on probabilities, not certainties. And it is very rare to find an AI system that is 100% accurate. Okay, so this is a fact. All AI systems will not be 100%, AI systems will not be 100% accurate. Now, why this matters in critical systems? So for routine business decisions, a small error may be acceptable. But when AI is used for consequential decisions, the cost of an incorrect decision is very high. Okay, let me give you some examples of high stakes decision. For example, beneficiary identification systems or criminal identification systems or social welfare schemes. Suppose your friend met with an accident, you take him to the nearby hospital. He is enrolled with a particular health scheme of the government. He punches in, the AI does the thing and founds him ineligible. Now consider if there are 10% errors, you can imagine 10% of the people, 100 people going, 10 people will be devoid of the services. And that's a big thing when it comes to healthcare. Okay, or similarly in autonomous systems, driving cars, 10% might not be acceptable at all. Okay. So in these cases, any incorrect decision could lead to exclusion from services or benefits, violation of fundamental rights, or loss of trust in the system. Okay, so we need to be careful when, uh, for example, in a say a beneficiary identification system, an incorrect decision could mean a citizen is denied benefits that they are legally entitled to. In criminal identification system, an incorrect decision could lead to wrongful accusations. It could lead to violation of fundamental rights also. Okay. So, and another important issue is automation bias. So people may overtrust AI systems because they assume machines are always correct. That is also a problem. So this over dependence can worsen the problem also. So what should be done? So when AI systems are used for critical services, it is essential to have clear objection and redressal mechanism. Most important, human intervention, human in the loop. You must have heard about this terminology. This is very important. Regular audits and checks and transparent processes. Okay. So let me explain this consideration with an example. So this is a real world example from India itself that shows how AI can be used responsibly in high stakes public services. So we are not pointing any mistakes here, but we are just trying to highlight how the system has been defined by the National Health Authority to take care of that false positive part. Okay. Or rather a false negative part. So National Health Authority is responsible for implementing India's public health insurance scheme, which is PMJAY. Now, under this scheme, beneficiaries receive cashless treatment. Okay. They can go to any empaneled hospital across India, and PMJ makes payment directly to the hospital. This is the scheme, PMJAY scheme. Now, what is the challenge? So this scheme processes a large number of insurance claims every day. So naturally, there is a risk of fraudulent claims. Okay. Now, to detect and flag such cases, AI systems are used. Now, let me define the key problem here. The key problem is high social cost of wrong decisions. So in this system, if the AI flags a case as potentially fraudulent, it does not stop treatment. I repeat, the system is designed in such a way that if the AI system flags that this is a fraudulent case, the treatment will not stop because the social cost of an incorrect decision is very high. So imagine stopping treatment for a genuine patient just because an AI flagged the claim. That would be unacceptable. Okay, so that is what we are talking about. So how the system works? Let me explain it to you. So what happens when a case is flagged? Suppose a case is flagged as a fraudulent case. What happens? So the AI system sends the flag and reasons to the state anti-fraud unit, SAFU. The SFU investigates the case. The patient receives treatment without delay. There is no delay in the treatment of the patient. Payment to the hospital is released only after the case is verified. Okay, I hope you got it. Patient is not denied treatment even if the AI system flags it as fraudulent. It goes to a SFU anti-fraud unit. They take their time to verify it while the patient gets the treatment. Only the payment is not made. So the AI system here is developed by a vendor selected through a public RFP. The vendor selection is also very important. And the RFP includes specific requirements to ensure fairness and accuracy. Okay, so the key RFP elements includes minimize false positive. For example, false positives, just to explain it to you, false positives mean genuine cases being flagged as fraud. So explicitly, the RFP, the false positive clauses are included in this, that the RFE reserves 8% weightage for adaptability to incorporate feedback and reduce false positives. What it means is for 8% cases, it refers to NFU and get it verified. There is also an outcome-based payment structure, that the vendor's payment include a variable component based on true positive ratio, and that is genuine fraud detected. Okay, so there's a performance linked. They have incentivized that also, and there is a minimum performance criteria to ensure fraud is not missed. A minimum threshold is also defined. Now, why this is important? So this design is a great example of responsible AI governance because it protects citizens from wrongful exclusion, ensures healthcare is not interrupted, and encourages continuous improvement of the AI system. Also balances the trade-off between the false positive and false negative. Okay, so the key takeaway from this consideration is AI systems should be designed to minimize harm, especially in public services. Okay, I think we have already covered this. Now coming to consideration number 5. Accountability. Accountability of AI decisions. Okay, so modern AI systems, especially those using deep learnings, are often opaque. A specific decision may be influenced by many factors, such as the training data, the algorithm selected, the model architecture and parameters, the development and deployment process, and the environment in which the system operates. Now, different organizations or teams may contribute to each stage of the AI lifecycle. Okay. So in legal terms, this is so this creates since there's a whole ecosystem of there's a team evolved, it creates a many hands problem with when multiple parties are involved. It becomes difficult to identify who is responsible if something goes wrong. Okay, AI system is a uh, is a solution which is touched by so many people, so many technologies. How will you blame? How will you hold the accountable somebody accountable if for a particular AI decision if something goes wrong? I'll straight away explain with this example, the case of Elaine. So in 2018, Elaine Herzberg was tragically killed by a self-driving test vehicle operated by Uber's Advanced Technology Group. And this was the first recorded fatality involving a self-driven car. Okay, let me explain what happened. So Uber had modified the vehicle with a proprietary automated driving system, and a human backup safety driver was present in the car during the test. But at that time of the crash, the driver was distracted and looking at his cell phone. Okay, now imagine the environment. The road conditions were normal, dry road, street lighting, no extreme weather. Okay, now what uh, what was the findings of the investigation? So the National Transport Safety Board investigated the incident and found, and some of the key findings were, so there's a whole lot of finding, but I'll just cover it quickly. That the Uber system detected the pedestrian 5.6 seconds before impact. Okay, this is pedestrian. If I remember correctly, she was crossing the road and she got hit by this car. So it detected the pedestrian 5 seconds before impact, but the system never accurately identified the pedestrian as a person and failed to predict their path. The system tracked the object but did not classify it correctly. Therefore, it did not react appropriately. The human safety driver was inattentive. So if the driver had been attentive, they likely would have had enough time to react and avoid the crash or reduce its severity. Uber's oversight was inadequate. Uber had the ability to monitor safety drivers' behavior, but they rarely did so. Additionally, Uber had removed a second operator from the vehicle, reducing oversight further. Now, this uh, is accountability issue. I'll explain to you. So this case raises a serious accountability problem. Was the crash caused by the automated driving system or the safety driver or the Uber's management and oversight or the design of the technology itself? Because multiple parties were involved, assigning liability became very difficult. Okay. So of course, after this incident, Uber stopped testing self-driving cars in all cities. Other companies also paused road testing, and it led to a major setback in autonomous vehicle development worldwide. Okay, but what were the changes? So Uber implemented several changes to address the deficiencies. They implemented a safety management system, increased monitoring and oversight. But the key takeaways from this system consideration, from this example, which formulated this system consideration, is that accountability in AI is not straightforward. Complex systems involve multiple stakeholders. And when something goes wrong, it is difficult to assign liability. And this can lead to legal uncertainty, public distrust, and loss of business momentum. Okay, to uh, rephrase it in simpler language, if the car hit, who has to be blamed? The car owner, the car driver who was a standby and inattentive, or the software engineer who designed the algorithm, or any other part. So whether the engineer needs to be blamed, or the car owner has to be blamed, the company needs to be blamed, or what? Okay. So this is that created this system consideration that there has to be accountability of AI decisions. Okay, when we study, if you join, when we study ISO 42001, you will get some clarity as if you're an organization, you are developing an AI product, who has to take the ultimate accountability. Okay, we'll discuss that in that class. However, in this, you understood the importance of accountability and the complexity involved with uh, fixing the accountability. So we move to system consideration 5. Okay, which is privacy and accountability of AI decisions. Privacy and accountability of AI decisions. Okay, so I'll straight away cover this example and try to explain you the crux of the matter. So I'll explain you this high-profile example called Clearview AI. So what is Clearview AI? So Clearview AI is a US-based startup that developed facial recognition technology. Okay, and this company built its system by scraping over 3 billion images from social media platforms such as Facebook, Instagram, and Twitter. Okay, so Clearview AI provided this technology to law enforcement agencies, claiming that it helps identify criminals. And the company's stated mission was to assist law enforcement in identifying individuals involved in criminal activity. Okay, but why is this controversial? Because there were multiple reasons. Lack of consent. So the images were scraped without the consent of the individuals. So people's faces were used for training without their knowledge or approval. Okay, that's why we have a DPDPA now. You can't store anybody's PII data unless you get a consent from them. Lack of transparency. So law enforcement agencies often use this technology with limited understanding of how it works. In other words, they were relying on a black box systems to identify individuals. And there was a mass surveillance risk. So civil society groups raised concerns that this technology could be used for mass surveillance, tracking citizens without any legal oversight. And they consider this as legal violation. And from there, this consideration has come of privacy risk. So if you want to include PII data, you need to take consent. And that is what it's all about. And the last is security risks. Okay. So I just briefly explain. So AI systems are fundamentally different from traditional software systems because they are data driven and depend on complex models. So this means that the system can be attacked at multiple points during training, during deployment, and during inference. I just briefly explained, so there can be multiple attacks like data manipulation attack. Okay, so AI systems rely heavily on training data. And imagine if attackers can manipulate the data used to train the model, they can influence the model behavior. There can be adversarial attacks, which are specifically designed to exploit vulnerabilities in machine learning models. They introduce small changes in input data that are hard to notice, but cause the model to make wrong decisions. So they basically this consideration was to bring out the security risk with AI. And that sums up our system considerations. There are 7 of them. Okay. And with this, I've come to the end of this lecture. Already consumed 3 more minutes. Okay, so if there are questions, quick questions, I would like to answer them, or we'll pack up for the day.
I just have a question. So my name is Shogoto Das, and I presently I work with responsible AI, and I was unfortunately in one of the teams for the Watson rollout for healthcare. So you covered that. Now, one of the things which I found it missing here, or maybe that's a broader topic, is how when you launch a product and if the user base is geographically quite vast. For example, it can be in Europe, it can be in US, Canada, or India, as well as the Middle East. What are the system considerations that we should keep in mind? Because this is one of the real challenges that happens when you roll out a product, especially internet like product over the internet or any web-based product. So that's one of the challenges that we face in a day-to-day basis. And second challenge would be like there would be conflicting rules, right, in certain countries, especially with the financial domain. So how do we deal with that, or what are the design considerations that we should have? Hello.
It's on mute.
Sorry, am I audible?
Yes, you are audible, Sugat.
Okay, thank you.
I could hear the question. It seems Ashish sir is on mute.
Yeah, so what I did was I rephrased your question for the entire audience. So I think the first question was, if you are making an AI product and support it has the applicability throughout the planet, and then obviously it has to be fed with that kind of training data from different parts of the world. So that is a challenge for sure. Okay. So how do we deal with that? Is that your question?
Yes, and moreover, like you covered ISO 42001, right? That is good for India. But how about like when you roll out the product globally, because there would be other agencies that or other review boards that set up their quality controls, and sometimes there are conflicting clauses. That's what we have come across. Like the bird clause for Europe and US are like conflicting, typically in the financial domain. For example, I'll give you a small example. In India, no operator can ask you for your credit card number. That's considered illegal, right? Whereas in North America, the operator can directly ask for your credit card number. That's perfectly legal, right?
Okay.
So,
Okay, I understood your problem. I think and there is no standard answer for these questions, and they depend on the change management or how the organization is going to roll out the product. So probably in the first case where we are aware that data has to come from the different nooks of the world, I think the practical way to handle will be to understand first the the places where the data are coming, and we should have enough samples from every part. We must check whether there are some regions which are heavily over represented, and those areas should be identified. We should not just blindly mix, everything together, because geographic differences can create distribution shifts. So it's a very gradual, step by step process that the AI product has to be trained gradually and then tested to ensure that it is learning properly and there are no deviations. So of course, the training data has to be balanced. That I think your question said it all. That it has to come from all the represented and even under represented regions. Uh, Maybe underrepresented regions need to be oversampled, and the dominant regions maybe need to be undersampled, so that there is no bias, that it picks up during the training, as we saw in the recruitment application where we had more men applicants than women. So that balance is also needs to be maintained. So the areas which are underrepresented, maybe you need to do oversampling there. Areas which are dominant, maybe you need to undersample there. Some mathematics has to go there. And and then the data, the training data has to also have to, you have to assign training weights to those regions. And uh, so use a stratified sampling to do that. Also, um, if you have plenty of data from one region, but little data from another, there are a lot of techniques, uh, you know, which can be used, like domain adaptation and region-specific fine-tuning needs to be done. Uh, but in these cases, and especially, um one of the biggest mistakes in geographically diverse data is we can't split the data randomly, just like that, like 80% train and 20% test. Instead, we can consider something like the training data can come from, say, India, Europe, and North America, and maybe test, can be from Africa. So there is something called geographic cross validation, which needs to be done. So those things have to be taken care of, uh, such that the uh, model that you are using can generalize to a new geography. Okay. So these things are the other part is, and I think if I am the AI officer, I would not launch my products, straight away for the entire planet. I won't do that. I would rather restrict it to one region, test it in my training thing, then try it in a particular region, and then slowly scale it to other regions. Okay, it is like how the government rolls out policies, like it tries in certain states, uh, understand, because you can't make a perfect policy. Okay, so there will be issues, even if no matter how perfect you become, you pull in the best of the talent. Even if you have practiced or done that before, even then there will be issues. So I think the and it's my opinion that you should slowly scale it up, especially forget about the entire world. Even if you're launching it in India, you need to scale it up. Identify places where people are open for adaptation. They can adapt to new products. As far as my knowledge goes, I've always seen new models coming up in Bangalore and South Side. The first EV vehicle was launched there 20 years back. So uh, maybe launch something there, learn, and then try to scale it. That is what I think you should the best option to do that. Okay.
Yep. Thank you.
Hello.
Yes.
I have one more question. Like, can stakeholder play a larger and more crucial role in a setting up framework in different domain for AI and risk in a more proactive fashion rather than the reactive fashion?
Which stakeholder are you talking about? Can you be specific?
All domain for different domain like stakeholder, AI stakeholders like finance, healthcare.
Okay. So can you tell me who decides whether an AI product has to be made, has to be developed or not?
Business head, board members.
Exactly, exactly. It's just like, project management. The top management has to approve. Okay, max they can do is they can earmark a person who is the chief AI officer, and he has to decide based on the various risks that and after it closely examining all these aspects that we just went through, whether it has to be launched or not. Okay, and then he should take the full responsibility and accountability of that. Okay, now coming back to your question, just repeat the question once more.
Can a stakeholder play a larger and more crucial role in a setting up framework in different role for AI and risks?
So now it answers your questions. The main stakeholder, see, because as we were discussing, accountability is a very tricky scenario in AI because there are so many stakeholders involved. So it is difficult. Like in that case, it was difficult to fix an accountability. Tomorrow's a AI based say autonomous vehicle kills somebody, then who has to be responsible? Okay, so that should be clear. So if in your organization, if you wants to develop an AI based product, the chief AI officer has to have all the accountability. Okay, and when he takes the accountability, he's the one who will decide which frameworks to be followed, what is the procedures. He can take the call. I think that answers your question.
Yeah. So like how do we translate the AI risk to stakeholder in a way they can understand?
How do we transfer AI risk? These are,
Translate AI risk to stakeholders.
so that depends on the kind of application that you are developing. It. I mean, you can't simply hand an AI risk to a stakeholder and say, now this is your risk. You have to identify the risk, assign responsibility, ownership, select a treatment, include some kind of transfer or share where it is appropriate, and of course, obtain acceptance of the residual risk. So it is a chain, that happens. You identify, you assess, treat, then assign, communicate, of course, accept, and then monitor. All those things have to be done at different level. So if you talk about the um, uh, you know if you talk about an AI company, then probably at that level the model can be a risk or a responsibility. And uh, if the company is developing this or getting it developed from, say, a second firm, then it can enter into some kind of a contractual security requirements or a SLA and pass it on to them. Okay. If there is an IT team which is uh, for which the risk part is secure integration, then probably it can place the necessary access controls or encryption or some kind of monitoring to handle that risk. If there is data, especially the PII data, there is a data owner defined. So those sensitive data which are entering AI, you how do you treat them? You probably would like to classify them, mask them, or take approval when it is, if it's a PII, you need to take approval, take consent from the data principal. I think that is how you handle.
So sometimes but oftentimes product team will come up with the AI and business will stakeholder will ask for accountability. There is a large gap here. How do we fill that gap? Can you tell?
Yes, I completely agree. There is a large gap there. And the 42,000 says that the chief AI officer, or at least it means to that, in those many words, that the chief AI officer should be held responsible. But why will chief AI officer only take the responsibility? So that's a tricky thing, and that will vary from organization to organization and the kind of leadership that organization is following. Probably, uh, that might be happening. The chief AI officer may be held responsible, like a business leader or the head of the organization is held responsible for everything. Or for a cybersecurity crime, the business leader is responsible, but or CISO is responsible. The chief AI is responsible also, but he may, uh, formulate duties and responsibilities down the line and held other people also accountable and responsible. That is how, otherwise only he will be responsible and the people will have a ball of time. So that cannot happen. Okay, one last question because I have a class, coming up in another 5-10 minutes.
Good morning to
Good
this side.
afternoon, sir. Am I audible?
Yes, you are audible.
Okay, so good afternoon. My question is quite simple, but it's more of like a confirmation. But I wanted to ask you something. So, my question is basically, we train AI agents, like we feed data to any AI system, and that's how they work. So, if we train any AI agent or system, is it kind of risky or dangerous to provide the personal data or any company's data to that certain AI agent, like to maintain the transparency between the company and the uh, AI module we are using? So, like, is it to a certain extent, obviously? So, is it like kind of risky or dangerous to provide these data?
Okay, the answer is if it is PII data, okay, if it is
Okay.
PII data, then it is illegal. You need to take consent of every legal entity that owns that data. So if you go through DPDP, there is something called, okay, PII is personally identifiable information. Okay, so for any person like me, you, our Aadhaar card, our name, our address, telephone numbers are all PII data, email address, the IP address from where you're logging, any biometric information, government ID, home address, phone number, all are PII data. So first rule, and it is not risky, it is illegal as per DPDPA. It is, you cannot record. Okay, it is like you go to West Side. Next time when you go to West Side and when you go approach the counter and the guy asks you, what is your phone number? You ask him, I'm going to share my account, my mobile number, but if you lose it to a third party, are you in a position to pay 240 crores? Because that is the penalty. Okay. So
Oh.
even if he stores it with your consent, he has to protect it. Okay. You go to a pan wala shop, if he is noting down your number or with that intent to digitize it later, that is put it on an Excel sheet or something, even then he is under the ambit of DPDPA. Okay. So it is that
No, but
serious now.
like
So
sometimes
yes,
I
if you
do
are
give my
coming back to your question, anything, if you're feeding anything to AI application, find out who is the owner of that data. If it is a PII data, the data principal, like if you're feeding my Aadhaar number, I am the data principal. You have to take my consent explicitly. When we will have a
I
DPDPA class, I'll explain you that. Or if you take a
okay.
data which belongs to somebody else, you have to take a consent, their consent. Then only you feed it.
Actually, what if I'm feeding my AI agent according to me and it's my personal data? So is it like risky for even for me if I'm putting my data into it?
Who is the developer?
Um, Assume that it's me, obviously.
So are you developing? I mean, if it is riding on an LLM, I will not assume that you have developed the LLM by yourself. You must be using, APIs of ChatGPT and all to connect to them. So anyway, it is going there.
Okay. Okay,
You
I
must be using
understand
some
now.
models which are, pre-made models. So anyway, it is going
Yes.
there. Okay.
Okay.
Like for
Okay.
example, government organization, why is India trying to come up with its own LLM? Because they know if everybody switches to ChatGPT, so that all data will go there. So there is something called data localization also, and we would like to protect it. Imagine all the entire military switches to ChatGPT and they start putting everything there. Or the police switches to ChatGPT, uses it for various purposes, not realizing. And this has happened that initially they felt it is helping them in framing the charge sheets and all that, but they didn't realize that the data is going somewhere else. For example, somebody commits a crime. As per law, the victim's name need not to come in the media. But if you're putting it on ChatGPT and framing the charge sheet, in a way, you are doing that, right?
Right.
So ignorance
Okay.
is one. Ignorance is one. But if you are in your specific case, if you are riding, if your application is riding on an LLM, which is not made by our country, you are risking your PII data.
Okay. Thank you.
Okay, that was the last question. Thank you. Thank you for patiently listening to this. This was a little theoretical. That's why I jumped directly to the system consideration so that it will be of interest of all the students of different backgrounds, engineering, public policy, and management. Okay, thank you. We'll meet, I think, tomorrow in case you're logging in with a different topic. Thank you.
Thank you so
Goodbye.
much, sir.
Yeah.
Thank you.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Have a good day.
Thank you, everyone.